Okay, my children. Now, in the previous exercise, what are the points we have learned? Tell me. In the previous exercise, what are the points we have learned?
The degree of the polynomial.
So degree of the polynomial.
Degree of the polynomial. In 2.2, I mean in 2.2, in
So
2.2
zero of the
exercise.
polynomial.
Yes, we mainly focused.
Constant.
Yes, we mainly focused on finding value of a polynomial, when the value of x is given, when the value of the variable is given. And the second point is finding zero of a polynomial. Yes or no? Now, let us take one example before going to start the concepts. Okay. We focus on dividing a polynomial by a linear polynomial. Especially, we focus on dividing a polynomial by a linear polynomial. So, suppose x square plus 2x plus 3 by x plus 1. How do you divide this polynomial by x plus 1? In this exercise, we mainly focus on dividing a polynomial by a linear polynomial. Okay, my children. So, long division, x plus 1. We wrote this one as a divisor. This is a dividend, x square plus 2x plus 3. Now we had to find quotient and remainder. Please listen these steps carefully, my children. When you are writing divisor and when you are writing dividend, the terms of the polynomial should be in the descending powers of x. So we write highest power of the x term. After that, next highest power of the x. After that, next power of the x. So here see x square is highest power. Yes or no? Highest power of x is 2. So we wrote x square term first. After that we wrote x term. After that we wrote a constant term. So remember this point. In the descending powers of x, we have to arrange the terms of either divisor or dividend. Sometimes they will not give the polynomial in this order. We have to arrange the terms of the polynomial in the descending powers of x. Means, first of all, we have to write highest power of the variable. After that, next highest power of the variable. After that, next highest power of the variable. In this way, we have to arrange the terms of the given polynomial. That is called descending powers of x. Okay, descending powers. Here x square. What is the power of x here? Exponent of x here 1. Here the exponent of x is 0. So 2, 1, 0. So in the descending order, the exponents of x are in the descending order. Yes or no? Similarly, the exponent of x is 1 here. Here this is a constant term. So its degree is 0. Okay, so we arranged the terms of the polynomial in the descending powers of x. First and first step is we have to write any polynomial in this order. Okay, please remember this point. Okay, my dear children. So before going to this division, I will take some examples. You have to write the polynomial in the descending powers of x. First, I will check how far you can write the given polynomial in the descending powers of x. Okay, I will discuss this point later because that point is very important in this division, this long division. Now I have given a polynomial. I have given a polynomial. Are the terms of this polynomial arranged in the descending powers of x? Or the
No,
terms
sir.
of this polynomial are the terms of this polynomial in the descending powers of x?
No, sir.
Now
No, sir.
tell me the terms in the descending powers of x. Tell me the terms of this polynomial.
So minus
What is-
x power 5
Very good. Minus x power 5.
minus 5x power 3.
Minus 5x cube.
Sorry, sir.
Ah.
Plus 4x
Okay.
square
Plus 4x square.
plus 2.
Very good. This is called standard form of a polynomial. This is called a standard form of a polynomial. When a polynomial is written in the descending powers of x, then the polynomial is said to be standard form. What is this form called? Standard form. I will give another polynomial. Are the terms of this polynomial in the descending powers of x?
No, sir.
Only Bibina. Every time Bibina only responding to my question quickly and fast. What about other children? Don't you know the answers or simply you have a system simply sitting silently? Are the terms of this polynomial in the descending powers of x? Tell me.
No, sir.
Uh, it's simple answer, yes or no. That only I am asking. That also can't you tell me yes or no? That's all. Of course, it may be right, it may be wrong answer. Okay, so the terms of this polynomial are not arranged in the descending powers of x. Now tell me the terms of this polynomial in the descending powers of x. Arrange the terms.
So 100x square.
Is this highest power of x? Tell me. Power.
So
Power of
minus
x
10x
is highest.
power 6. So minus 10 power 6 is the highest power.
No, that only. First we have to write this one, not this number. This is coefficient. This is called coefficient of x square, not power of x. Not power of x. Just wait, my dear Bibina. Just wait. And Mahima, both of you, wait. Srujana is to, sorry, Santi. Santi is telling minus 10 x power 6.
10 x power 6.
Next,
5x power 4.
5. Before 5,
Minus
no,
5.
why
Minus
are
5.
you? Why are you not telling minus? Why are you not telling minus 5? Minus 5 x power 4.
Minus x power 3.
Minus x cube. This is called x cube. Especially it is called x cube. Okay. Remember this point. Next.
Minus 100x square.
Minus 100 x square.
20. Minus 20. So
Minus
plus 20.
Minus 20
Plus
or plus 20? Plus 20.
Plus
Before
20.
the number, you have to find out the sign of a number or sign of a term before that. Okay, left side that number. So plus, there is no sign, we consider it as a plus sign. Okay, my dear Shanti?
Yes, sir.
Okay, my dear children, understood this concept, writing a polynomial in the standard form. Nikita, Krish, Srijana, Janej, Anmol,
Yes, sir.
Mahima, Trinson. Okay,
Understood, sir.
I will give another polynomial because these are basic points. Without knowing these basic points, we can't go further step. We can't go to the further step. This is the given polynomial. Now tell me, is this polynomial in the standard form? Is this polynomial in the standard form?
No, sir.
What is meant by a polynomial in the standard form? The terms of the polynomial should be arranged. The terms of the polynomial should be arranged in such a way that descending powers of x. Okay, the terms of the polynomial should be arranged in the descending powers of x. Yes. Tell me, what is the first term? Okay, Mahima, now your turn. Okay, Mahima, tell me.
Okay, sir. So minus 5 by 3x power 5
Yes, very good. Minus 5 by 3 x power 5
plus 100 plus 3,
plus
100x cube
100x cube plus 100x cube.
minus 4x square
Wait, my dear Samuel, my dear Bibina, please wait. Mahima is telling answer. Please listen this carefully. Janej, Samuel, please listen. She is telling answer. If she tells wrong answer, I will give you chance. Okay. Minus 4
4x square
minus.
minus x.
Very good. Okay, my dear children. I will ask one more last question. Same like this. Same on g of x. Another polynomial. I have taken a polynomial in the variable. So not every time variable x only. Why to take variable x? Let us take variable y now. Let us take a variable y. Okay. G of y. I am taking a polynomial in y. Just wait, my dear Janej. Just let me write the polynomial completely. Let me write the polynomial completely. Okay. This is a polynomial in y. This is a polynomial in y. Are the terms of this polynomial arranged in the standard form? Are the terms of this polynomial arranged in the standard form? Yes. Yes. Tell me. Now tell me the polynomial in the standard form. Now tell me this polynomial in the standard form. Wait, my dear Bibina, Janej. Now the turn for Janej. Tell me, Janej. Yes.
5 by 3 y power 10
So first term is 5 by 3 y power 10
minus 100 y power 5
minus 100 y power 5
minus cube 3 by 10
minus y cube by 10
1 by 2 y power 2
before 1 by 2 no sign. What should be taken as a sign? Plus a sign or minus a sign?
plus
Then why didn't you tell that plus a sign? Plus 1 by 2 y square. Okay. So this is called standard form of polynomial. Understood this point, my children? How to write, how to arrange the terms of a polynomial in the standard form. Okay, my dear children. Understood?
yes sir
Understood this point or not?
Understood, sir.
Okay. And yes, okay, Srijana, okay, ma, okay. So this is important point. Whenever you are writing a polynomial, wherever you are writing a polynomial, it should be in the standard form. Standard form of a polynomial means we have to arrange the terms of the polynomial in the descending powers of the variable, in the descending order, of the powers of the variable. So y power 10, y power 5, c y cube, y square, y, and so on, like this. Okay. So this is the first and foremost thing. When you are adding or subtracting, when you are multiplying or when you are dividing, whatever the operation you are performing on the polynomials, first you arrange them, then in the standard form. Okay, so this is the first thing you should remember this point. After that, come to this division. So we are dividing this polynomial x square plus 2x plus 3 by x plus 1. Now let us take this example. Divide x square plus 2x plus 3 by x plus 1. So we are dividing this polynomial by this polynomial. Okay. Already this is in the standard form, this is also in the standard form. This polynomial also in the standard form, this polynomial is also in the standard form. So no need to rearrange the terms of these polynomials. X square plus 2x plus 3. Okay. Yes. So how to divide this polynomial by this polynomial? Please remember these points. Please listen these steps, my children. Step 1. What is the first term this dividend? What is the first term in this dividend? Tell me.
So x square.
So write here x square. Whatever the term, first term is there, write here as it is. Divided by. In this divisor, what is the first term?
So x.
Yes, divide that by x. Here, first term in the dividend by first term in the divisor. That's all. Don't consider remaining terms in this polynomials. Okay. Then tell me x square by x. What will you get here?
So x.
Sir, X, sir.
Very good. X. You should write this one in the quotient part. Whatever you got here as a result, write it in the quotient part. Then, how to write here? How to write here? Do you know long division? How do you write? So suppose 20, Suppose 3, 41. How do you write? 3 ones, yes or no? 3 into 1. We are multiplying this number, this number into this number. After multiplying these two, we write here in the long division. Are you following the steps or not?
Yes, sir.
So here to write the result, what should we do? We have to multiply these two. We have to multiply these two and we write here in the next line. Okay, so x into x plus 1. Tell me, multiply these two expressions. Have studied or not multiplying expressions? Multiplying a binomial by a monomial. How to multiply? Distributive property.
So x square plus 1.
X
1x.
X square plus
1.
Yes, sir.
not Mahima, 1, not 1 Mahima. X into x square, x into 1. Don't write this number as it is here. You have not multiplied. You have not multiplied this 1 by x.
Okay, sir. Okay, sir.
Okay. Yes. So x. Whatever the polynomial you got here, write this polynomial as it is as a second line. X square plus x. Then what will you do here? Suppose 3 ones 3. After writing this number, what will you do here? What will you do here?
So subtract.
Very
So
good.
subtract.
Very good. Very good, Princeton and Bibina. So we follow the same. We follow the same procedure here also. Subtract this polynomial from this polynomial. X square minus x square. What will get here? Minus. Change the sign. Do you remember this rule? Do you remember this rule? Change the
Yes,
sign
sir.
of every term in the second line. Okay. So plus x square is there. Change it as minus x square. Actually plus x is there. Second term. We change it as minus x. So in your mind, you should consider minus x square. In your mind, you should consider it as minus x only. So x square minus x square, what will you get here?
So 0.
So 0.
So they gets cancelled. The two terms gets cancelled. 2x minus x, what will you get here? X. Yes or no? 2x minus x. X.
Yes, sir.
Plus x.
So subtraction is over. After that, what will you do here? After subtraction in this one,
Sir, we'll
4
bring down the another number.
next digit. We bring down the next digit. We carry down the next digit. Yes or no? In the numbers, digits are there, whereas in the polynomials, terms are there. Yes or no? In the polynomial, terms are there. So we carry down this term. We carry down the next term. That is, what is the next term? Plus
So
3.
plus.
In the place of digits, in the number system, we carry down the digits in the division. Yes or no? Similarly, in the case of polynomials, we carry down next term, not next digit. Okay, carry down the next term, that is plus 3. So this is x plus 3. Okay, my dear children. Again,
Okay, sir.
take this first term. Again, take the first term here. Again, take the first term. What is the first term here?
Sir, x.
X. Very good. By again throughout this long division, we write it divided by x. Divided by x only. Whatever you wrote in the first step, we repeat the same in the denominator. In further steps also, we write the x as a denominator throughout this long division. Then what will you get here?
So 1.
So,
So we have to write this term in this quotient part. As it is a polynomial, we should write sign also. Don't simply write 1. It is meaningless. x1. It is not a polynomial. What should we write here? X plus 1. Here 1 is there, so 1 means plus 1 only. Then it is said to be a polynomial. If you write x after 1 without any sign, it is meaningless. It is not said to be a polynomial. So plus or minus should be there. So we write here plus because there is no sign. So multiply this number into x plus 1. Yes or no? Again, what will you do? Again, multiply this divisor into this one. What will you get? 1 into x plus 1?
So x plus 1.
X plus 1. Very good. Whatever the polynomial you got, just to cut, copy, paste here. Just below this polynomial. X plus 1. Again, subtraction. Again, subtraction. So change the sign. What will you get here? X gets cancelled. Okay. 2, 3 minus 1.
-2, sir.
Minus 2, Trinson.
Sir, plus 2.
Minus 2 or plus 2, Trinson?
+2, sir.
Don't be confused. Don't be confused here. So plus 2. So this is a constant. That is okay. That is hereafter we don't divide because degree of the polynomial is 1. Okay. Here degree of the polynomial is 0. Constant polynomial. No variable is there. So we stop this division. This is the remainder. Okay. Understood these steps and these,
Understood, sir.
understood this long division.
Understood, sir.
These steps, when you are dividing a polynomial by another polynomial, especially by a linear polynomial, we extend this concept further later, but in this class we mainly focus on dividing a polynomial by a linear polynomial. Okay, this is an example of dividing a polynomial by a linear polynomial. In the page number 36, okay my children, in the page number 36 and 37, they have given an example with detailed steps. Once go through these 2 pages also. Once go through these 2 pages also in the textbook. Now, is it a long process or not? What is the remainder here? 2. Okay. What is the remainder here? 2. So, to get a remainder, if you divide a polynomial by a linear polynomial, if you want to find only remainder, is it a long process or not?
Yes, sir.
If God gives a gift for you, my dear children, if you want to find a remainder, when you are dividing a polynomial by a linear polynomial, then what will you ask? Oh my God, tell me a shortcut method, God. Yes or no? Do you ask your God or not? God,
Yes, sir.
tell me a shortcut method. This is a long process. This long division is a long process. I want only the remainder. When I am dividing a polynomial by a you are ask Google, Janesh. Will you ask Google? Okay. In your mind, Google is God. You can ask the Google. Okay. So here we focus on finding a remainder when you are dividing a polynomial by a linear polynomial, especially only linear polynomial. We are focusing and we are discussing this concept only, not anything else. Okay. In this regard, there is a theorem. A mathematician discovered. Yes, we get. Okay, I will explain by another example. Divide.
Sir, can you explain that another method also, sir?
Another method is also there. That is synthetic division. That is called synthetic division. In 10th class or in higher classes, you can learn that. That is called synthetic, Turner's synthetic division.
Sir, then reminder theorem you was about to teach, sir.
Yes, I am going to teach. We are going to discuss remainder theorem. A mathematician discovered, he invented remainder theorem to find the remainder when you are dividing a polynomial by another linear polynomial. So Mahima asked, who asked, can you get
Sir, Mahima only.
remainder 0? Yes, I will tell you one example. In this example, we get remainder 0. Okay, divide divide x square plus 5x plus 6 by x plus 2. Now let us see in this long division, what is the remainder we are getting in this long division? Let us see here. First of all, previously also I told you, first we had to check whether the divisor and the dividend are in the standard form or not. Are these two polynomials in the standard form or not?
Yes, sir. Sir, but if it
Yes,
is
sir.
not in the standard form, we can change it, sir.
Yes, that only I am telling you. Right from the beginning. That is why I have.
Sir, then the question will itself change, no, sir?
No, question will not be changed. That meaning of the question will not be changed. If you rearrange the terms of a polynomial, the meaning does not change. Just we are rearranging the terms of the polynomial. Finally, both are same polynomials. Both denote the same polynomials. This polynomial denote the same polynomial. This polynomial denote the same polynomial. This polynomial and this polynomial denote the same polynomials. But for long division or any case, whatever the case it is, we should arrange the terms of the polynomial in the descending powers of x, descending powers of y, descending powers of the variable. Okay, remember this point. That is why I spend more time for this concept. Arranging the terms of a polynomial in the descending powers of x, in the descending powers of the variable. Okay. The meaning of the polynomial does not vary, does not change.
Okay, sir.
Even though we are rearranging the terms of the polynomial in the descending order or ascending powers of x, meaning does not change. Meaning of the polynomial is the same. Okay. So here the polynomial is given in the standard form. This polynomial is also in the standard form. Now let us divide. And let us find the remainder. After this long division, yes, Bibina. Yes, very good. Right, 0 only. Yes, 0. Remainder is 0 for this long division. X square plus 5x plus 6. What is the first term?
Sir, x
Sir, x square.
Otherwise, my dear children, we discussed this Horner's synthetic division in the IIT Foundation. Okay, we will discuss. Please remind me Please remind me this concept.
Okay, sir.
We will discuss this point, not in the regular classes. In the IIT Foundation, we discuss how to get a remainder in this Horner's synthetic division. Very simplest way. That is why it is called synthetic. Synthetic means small, very small. Okay, shortcut method. Okay, we will discuss this Horner's synthetic division in the IIT Foundation period. Okay. Now we follow this method, these steps. What is the first step here? First term is x square by, what is the first term in the divisor? X. Then what is the quotient here? X.
The X.
So multiply, immediately write this answer here. Immediately write this answer in the quotient part. Immediately write this answer in the quotient part. This is the first term of the quotient. So after that, write this one. Write this sentence. Multiply these two, x into x plus 2. Multiply these two. What will you get here? X square plus 2x. X square plus 2x. Subtract. What will you get? X square minus x square gets cancelled. What will you get here? 3x plus, we carry down the next term. As I said for the previous example, the previous examples I told you, we had to carry down, we had to bring down the next term of this polynomial. Next step, take the first term. Again, we have to consider this is a new divisor, new dividend. This is a new dividend. Again, in the new dividend, the first term is 3x by this one as it is x. Previously, I told you that denominator comes continuously throughout this long division. What will you get? X gets cancelled, 3. Immediately, you have to write here plus 3. Previously, I also told you don't write simply 3. It is meaningless. You should write either plus 3 or minus 3. Then it is a polynomial. Then it is said to be a polynomial. So multiply 3 into x plus 2. What will you get? 3x plus 6. Write this polynomial in the next line. Now subtraction. 3x gets cancelled. 6 minus 6. What will you get remainder? Okay, my Hima? Understood this example? In this example, we got remainder 2. In this example, we got remainder 0. But if you observe, this is some lengthy process. Not difficult, but some lengthy process. But a mathematician discovered a theorem that is called remainder theorem. Remainder theorem. When you divide a polynomial by a linear polynomial, he said a theorem that is called remainder theorem. Now come to this remainder theorem. What is the statement of the remainder theorem? So before coming to the next class, all of you go through the page number 36 and 37, 35, 36, 37 pages in the textbook. Examples also there. Previously also I told you have to practice example sums, not only exercise sums. You have to practice example sums also. Okay. Page number 38. Please go through these 3 pages thoroughly before attending the next class, 35, 36, 37 and 38. Go through these 4 pages thoroughly. Okay. Now we will discuss the statement of remainder theorem. What is the statement of a remainder theorem? This is the main concept for us. But Starting this main concept, these are basic points. Without knowing these basic points, these are basic points. Without knowing these basic points, we can't go to the direct point. Okay. Now come to the remainder theorem. Let P of X, just I am writing the definition, that is that theorem, I am writing the statement of the theorem. That is also given in the textbook. I am writing the same. I am not changing anything in that theorem statement. Let P of X be any polynomial of degree greater than or equal to
So can you move the note little down?
or equal to 1 Is it okay?
Yes, sir.
Yes, sir.
Okay, ma'am? And
Okay, sir.
let A be any real number A be any real number if P of X is divided if P of X is divided by the linear, see here my children, linear polynomial x minus a, then the remainder is P of A. Simply in one line, in a single line, we can find the remainder with the help of this remainder theorem. When you are dividing a polynomial of degree greater than or equal to 1, and a be any real number, then if you are dividing this polynomial P of X by x minus a, then the remainder is P of A. What is meant by P of A? Anybody? Can you tell me the meaning of P of A? Previously, I told you P of A, P of 2, P of 3, P of 4 in the previous exercise.
Sir, value of the polynomial P of X, where X is equal to A, sir.
Very good for your memory power. Here we take this as remainder. P of A is a remainder. We get some number. That number is nothing but a remainder. Without using this long division, without using this lengthy process, simply we get remainder. We get remainder 2. Okay. By using this long remainder theorem, we can find the remainder when you divide a polynomial by a linear polynomial. We will discuss some examples on this remainder theorem in the next class. Okay, my dear children, please take rest. Now the time is 3 past 15 minutes. Okay, my dear children, now the time is 3 past 15
Thank you, sir.
minutes. Now you can leave the meeting. Take rest. Take care of your health, my dear children. Stay at home. Stay safe. Sanitize your hands frequently. Sanitize your hands frequently. Thank you, my dear Bibina.
Yes, sir. Thank you, sir.
Thank you all. And do your work sincerely and seriously. Submit your classwork notes. Some students are not submitting classwork notes. In the Google Classroom, some students are not submitting. I will tell them no, their names also. Okay, my dear Mahima? It's okay? So, whoever not submitted their classwork notes, please submit your classwork notes. Okay. It is also important. Otherwise, at least take the xerox, take the printout of the notes which I am posting in the Google Classroom. Collect them and file them as a single notes. At least if you don't have the time for writing the classwork notes, at least take the printouts of the notes. Whatever I'm posting in the Google Classroom, at least take the printout of the notes, okay, and file them. You have to show that at least when you are coming to the school, at least you have to show that notes. Without writing classwork notes, without taking the printouts of these notes, how do you learn the subject? Can you learn the subjects without classwork notes, without writing the classwork notes? Yes, you can't. So that is why I am forcing you to write the classwork notes and submit them. In any case, if it is not possible to write the classwork notes, in that case only I'm telling you, suppose any health issues are there, because of any health issues, if you are not able to write the classwork notes, then take the printout, at least take the printout of the notes, whichever I am posting in the Google Classroom. At least take the printouts and file them as a single notebook. Understood this point, my dear children?
Understood, sir.
Right. Please carry on, my dear children.
sir.
Carry on.
Thank you, sir. Bye, sir.
Bye, ma. Bye.
Thank you.
Thank you, ma. Divina. Thank you. What, my dear Jaresh, still you are online? Do you have next class or not? Janej and Nikita? Why are you not leaving the class? Why are you not leaving the meeting? Janej and Nikita, do you have next class or not? Do you have next class or not? Janej and Nikita. Why are you staying back online? Why are you staying back online? Nikita? Ma Nikita.